Welcome to the review video for graphing trig functions. I'm going to do a number of the functions from the review sheet, although not all of them. I'll be doing ones that represent skills that you need to have in order to do well on the test. So here goes. First of all, here are the 6 basic trig functions that you should be able to recognize and to graph from memory. So if you take a look at sine and cosine and cosecant and secant, they all have a period of 2 pi. That's something you have to remember for this test, because when you alter the period by changing the equation, it has to be 2 pi divided by b. So for those, it's 2 pi. For tangent and cotangent, the period is pi. So if we alter the period by changing the equation, the new period would be pi over b. So a lot of people are getting those mixed up. So please be aware of that difference. Also notice that tangent, cotangent, secant, and cosecant all have asymptotes that you must draw, and you must put them in as dotted lines. So you should practice drawing these 6 on graph paper, labeling the x-axis, and drawing these completely from memory in order to be good at drawing the altered equations. All right, here goes. Number 1 from the review sheet is a sine curve that has 3 changes: amplitude change, period change, and a phase shift. So here we go. Amplitude is the absolute value of A. Well, the absolute value of 3 is 3. Some people have been putting negative if it's negative. The negative is an indication of flip. It has nothing to do with amplitude, so we don't represent amplitude as a negative number because it's the wave height, and height is always a positive number. The period of a sine curve is 2 pi divided by b, and b in this case is 2, so 2 pi divided by 2 is pi, so the period is shorter than normal. And then the phase shift is c over b, and that's going to be pi divided by 2, and it's always opposite the sign. The sign is negative, so opposite negative is positive, and that is right. So that's the information we need to know to get started. Now we're going to kind of think about what sine usually starts with. So peek over. I have to get my pen away from my tablet to use the mouse. There we go. Peek over here. Sine starts at the origin right here. So we're going to start at the origin, and I know that we're going to have to shift this right. So if I make one period, 4 boxes, that makes this pi, that makes this pi over 2. So one box would be pi over 4. All right, negative pi over 4 and negative pi over 2. You do not have to label every line, but you have to label enough of them that you're not asking the person grading your test to label things for you. If you just put one label here and there, then you're asking me to do your job, and I will not give you points for labeling the axis. So for instance, if you just put pi here and left it there, that's not enough. So about every other line, and I'll be able to tell if your curve is graphed well without doing your work for you. So normally we would start at 0, but we're going to go pi over 2 to the right, so we're going to start here. All right, now we said the period was pi, and I made that 4 boxes. So it's going to end 4 boxes later to the right. 1, 2, 3, 4. Since I'm using that, I'm going to go ahead and label it 3 pi over 2. And so here's the beginning of one period, and here's the end of that period. Then I could go 4 boxes to the left, 1, 2, 3, 4, and there's my second period. You're always going to graph 2. So I've got my beginning and end of 2 periods. Then I'm going to finish the dot pattern. So if I begin here, the middle also hits the x-axis. And remember, we're doing the 5-dot pattern that is sine, the hill and the valley. So we're putting this pattern in place. Okay. So starting here, halfway to the middle, I'm going to go to my hill height, and my amplitude is 3. So having taken care of the phase shift already, and then halfway between the middle and end, I'm going to go down my amplitude height, and then I'm here, and I'm going to repeat the pattern, beginning up, middle, down, middle. So watch this, middle up, middle down, middle up, middle down, middle. So I've got one hill and valley and another hill and valley to draw. So here we go. Wacom tablet is always interesting if I'm able to actually make it look like anything. Notice that while I'm not drawing a perfect curve, I'm also not doing a zigzag. The curves at the peaks and valleys, actually that would have been, I did all that in one thing. Okay, that's terrible. All right, so up and then back down through this point. This is a little bit better. And I'm going to make sure that's a curve and not a sharp point. Going through that point and down and make a curve. And come back up and put arrows on the end of it. Well, I still didn't hit the point, but you get the idea. I'm not having zigzags with sharp points at the top and bottom. So this is a hill and a valley and a hill and a valley for 2 periods. And there's question number 1 with an amplitude of 3, a phase shift. So normally it would start here and go up first, but I shifted over pi over 2 to the right, so now it starts here and goes up. So there's my phase shift. My period of pi goes through a hill and a valley in the space from pi over 2 to 3 pi over 2, so that's pi units wide. All right, there's sine. All right, so I'm going to do a cosine curve now, also with 3 changes, amplitude, period, and phase shift. So this one also has an amplitude of 3. It's positive. Express it as a positive number. Period would be 2 pi over 2. So notice we're limiting this to numbers that pop up a lot. So again, we've cut this short to pi. And then phase shift, C over B, is pi over 2. Opposite of negative is positive to the right. All right, so this has got similar changes, but we're not starting with sine. We're starting with cosine. So if you remember your cosine pattern, cosine starts on the y-axis and ends up off of the x-axis up here in the very middle. We're down at the minimum value right there in the middle, and then on our quarter points we're actually sitting on the x-axis. So this is the big valley. There's our cosine pattern we want to do 2 of. Okay, and sorry, that's a strange sideways drawing. So here goes. Normally cosine starts on the y-axis up, and our amplitude is 3, so we would start up, but we've got a phase shift. So if a period is pi, I can make 2 periods fit by making 1 period 4 boxes. So this has a similar numbering scheme to the previous problem and to many of these problems, in fact. Negative pi over 2, negative pi. All right, so if I'm going to shift right, normally I would start on the y-axis. If I'm going to shift right pi over 2, I'm going to start here. My period is pi, and pi is 4 boxes, so 1, 2, 3, 4 is the end of my period. I'll go down and label that one. That would be 3 pi halves. So beginning, end, middle is here, and that's where I do my absolute minimum, 3 down. And then between beginning and middle, I'll hit the x-axis, and between middle and end, I'll hit the x-axis. And there's 1 period, and so I'm going to repeat this pattern over to the left. See how it goes up, middle, down, middle, up. And I'm skipping 1 box over every time. So from here, 1 box over, I hit the x-axis on the way down. Next box over, I hit my minimum. Next box over, I come up and hit the x-axis. And the final step, I end up. So here's my cosine curve. So making it curvy. I'm going to address a problem I'm seeing people do that makes a problem for them graphing and making it look right. Very briefly down here at the bottom. Try to avoid this problem. If you decide to make one box pi, then don't make the next box 3 pi halves. Something like this, where from here to here is supposed to be pi, and from here to here is only pi over 2. Those are same widths. So if this is from 0 to pi is 1 box, then the next box should be pi to 2 pi and should be the same distance between them. If it's pi units per box, then this is 2 pi and this is 3 pi and this is 4 pi. Don't make one box different widths from label to label. Okay. All right, right, let's look at another sine curve. This one is flipped, so I want you to see a flipped one. This actually does manage to have all four things in it, which I don't think I'm going to go quite this hard on the test, but they're all skills you need for the various problems. So amplitude is the absolute value of A, which is still 3 in this one. Period is going to be 2 pi over B. In this case, B is the coefficient of x is pi over 3. All right, and so we need to flip pi over 3 and multiply by 3 over pi. And the pi's will cancel, and we'll get a period of 6 with no pi on it at all. And then phase shift, C over B, is 3 pi divided by pi over 3. So I will flip pi over 3 into 3 over pi, and the pi's will cancel, and I'll have 3 times 3 is 9 for a phase shift. Opposite the negative sign is positive, or right. Okay, so normally sine would start right here at the origin, and if I make one box, I'm going to say each box is 3. 3, 6, 9, 12, 15, 18. Okay, that's pretty easy to count since it's not in terms of pi. I can do -3, -6, and I'll do more if I need it when I get there. Okay, so period of 6 shifted 9 units to the right. Normally sine starts at the origin, shifted 9 units to the right is here. So I'm going to draw my beginning dot there. My period is 6 units wide, so every box is 3, so 3, 6. There's the end of my period. So I've got to do my 5-dot pattern in the space of those 2 boxes, and I've got my beginning and ending dots. I have to put my middle ones in. Halfway over, there's a dot where the graph crosses the x-axis, and then I put my hill in the middle. Oh, wait a minute. Flipped. Instead of putting my hill first, I'll put my valley first, and I've got to go all the way down to -3. And then halfway between the middle and end, I'll go up, since this is flipped. And so there's one period. I can draw that in before I draw the next one. Hard to do well. Okay. This is why you should do this in pencil on paper. I'm trying not to make it a sharp point. Maybe if I start here and go up. That's a little better. Okay. And then hit the x-axis and come up. Make it a curve and come back down. There's one period of sine. So I'm going to do the same pattern backwards. 2 boxes wide is my period, so I didn't need to go that far. Halfway in the middle, I hit the x-axis. And my first quarter point, I'm going to go down because this is flipped. My second quarter point, I'm going to go up. Okay, and draw one more curve. That would seem to work well. So up is easier to draw well than down. And so there's a second period of my sine curve. Okay, let's keep moving. All right, here's a cosine curve. It is also flipped. So amplitude, I happen to pick all ones with 3. Sorry I didn't have more variety, but that's okay. Amplitude is the easy part. Notice I'm not labeling the y-axis. That means I'm assuming this is 1, this is 2, this is 3. All right, period for cosine is 2 pi divided by b, which in this case is 2 pi. So 2 pi over 2 pi is 1. I have a period of 1, which I might want to make multiple boxes just to make it easier to draw. And there is no phase shift. Notice, with no plus c value, then c is assumed to be 0, and there is no phase shift, so we don't have to write a shift at all. Okay, so here it goes. Cosine, we know, crosses the y-axis up. But this is flipped, so I'm going to start down. Okay. There's no phase shift left or right, so this is my first dot. And the 5-dot period, when it's been flipped, is a big hill. So it looks like this part of the sinusoid. And when I get to the end of a period of width of 1, I'm going to have another down dot. So I'm going to make 4 boxes equal to 1, and that's going to be the end of my period. All right, in the middle of my period, I'm going to be at my max. And then the first quarter point is on the x-axis. Middle, second quarter point on the x-axis on the way back down. I'm going to do the same pattern to the left of the y-axis. So from the rightmost dot, I go up to the x-axis one box over, and then one more box over, I'm at my max, and one more box, I'm down back at the x-axis, and one more box, I'm at the end of my period. So now I can draw this curve in. I'm supposed to hit the dots. Hopefully when you've got pencil on paper, you'll manage to hit them. All right, feel free to laugh because this is not easy, and then maybe come visit me in help session and try and draw it on this thing, and you'll see how hard it is. All right, moving on. We need to practice tangent. So I want you to take a good look at the original tangent curve. See how the first one we can draw that goes through the y-axis goes over to pi over 2 and has an asymptote on the right, and negative pi over 2 and has an asymptote on the left, and goes generally uphill. So we're going to keep that in mind as we do a tangent curve. So we don't call it amplitude with tangent because it's not a wave, but A is 2 because we want to take the absolute value. So absolute value of negative 2 is 2. That's going to be my shoulder height. Period of tangent and cotangent, by the way, is pi. So if we have a coefficient of x in our equation, we would divide it into pi. So then I would take pi, flip the 1/2 to multiply 2 over 1 times pi. So our period is 2 pi, which is wider than normal because the normal period of tangent is plane pi. And then there is no phase shift because there is no plus c. All right, so remember the thing about asymptotes? There's two little equations to solve. So I'm going to take my argument, bx plus c is actually just bx because there is no c. And you're going to set that equal to one of the original asymptotes, negative pi over 2. We're going to solve that, and then I'm going to take 1/2 x equals the other original asymptote, and I have two little equations to solve for the new asymptote locations. So the way that I'm going to solve these equations is to multiply both sides by 2. So these 2's will cancel. 1 times x is x, and 2 over 2 cancels, and I've got an asymptote at negative pi. Same thing over here, multiply both sides by 2, and I get x, and then 2 on top cancels with 2 on bottom, and I've got another asymptote at pi. So meaning there's nothing between these asymptote-wise. So if I make, so the period is 2 pi, so I've got to fit 4 pi on here. If I make 1 pi 4 boxes, I don't have enough room for 2 periods. So I've got to make pi 2 boxes. Okay, so each box is pi over 2, or half a pi. So you can label as many as you need to. Negative pi is 2 boxes. 2 more boxes is negative 2 pi. All right, and now we need to draw in our asymptotes at negative pi and pi. So here we go. And at pi. This is how wide the period is, 2 pi. So pi to the left and pi to the right equals 2 pi. So now I need to draw my tangent curve flipped because it's negative. Okay. You might want to write flipped over here in your work when you do finally notice that. So tangent always crosses in the middle even when it's been flipped, but instead of going generally uphill, it will go generally downhill, and that's where I have to use my shoulder height. Halfway to this asymptote, I'm going to go up to 2, and halfway to the right asymptote, I'm going to go down to 2. And in tangent reciprocal is flipped down, cotangent, and flipped tangent looks like cotangent. So there's that, and there's that part. And then I've got to do another one. You should hit this dot if at all possible. 4 boxes wide for the period, 1, 2, 3, 4. That'll put me at 3 pi. And draw an asymptote. And then repeat this pattern in the middle. In the middle, you put a dot on the x-axis. Do not move this down below the x-axis, okay? So over left and up 2, right and down 2, If I don't see these dots, I'm going to look where they should be, and if your graph goes through them, then you did it right. If you draw the dots, it helps you draw the graph. You know you're going to go through the right points. So learn to draw your dots. All right, and there's 2 periods of number 11. All right, moving on, we've got a cotangent curve to do. And if you recall cotangent, let's peek back at that real quick. Cotangent looks like tangent, but it's been shifted right because the asymptotes are not at negative pi over 2 and positive pi over 2 anymore, but at 0, pi, 2 pi, 3 pi, probably negative pi, negative 2 pi. And these go downhill. Same shape though, and same period as tangent, just 1 pi. So let's try our graph. There we go. And A, not really amplitude because it's not a wave, but it's the absolute value of 3, which is 3. Period, which is pi over b, and b over here is 1, so it's pi over 1 or just pi. So the period is not altered at all. Phase shift is negative c over b, or excuse me, c over b, pi over 2 over 1, which is just pi over 2, and then opposite plus is minus. So, or you could say pi over 2 left. So, we're not going to use this to shift the asymptotes because there's times when the asymptotes shift as they do, as the curve does, and times when they widen and don't merely shift. So, I'm just trying to teach you a way that works no matter how the problem's written. So, if we take our argument, which is what's sitting after the trig function, and set it equal to one of the original asymptotes, 0, we can solve for that one by subtracting off pi over 2. And that's 0. And x equals 0, take away pi over 2 is negative pi over 2, so there's an asymptote. And x plus pi over 2, this time it'll equal pi, because that's where the other asymptote is close to the origin for cotangent. If we subtract half of pi, so pi minus half of pi leaves half of pi. And that's what x is. So we're going to draw our asymptotes at pi over 2 and negative pi over 2, which is strangely like tangent. All right, so if I make 4 boxes pi, I can fit 2 periods on here. And there would be pi over 2. And 2 boxes left of the y-axis would be negative pi over 2 and negative pi. Okay, so drawing an asymptote at pi over 2 and at negative pi over 2. Now this looks like the phase shift because the period didn't change, but remember, we knew where to draw these because we solved these equations. Now cotangent passes exactly through the middle with an amplitude of 3 and a positive equation. It's still going to be a downhill curve. It hasn't been flipped. So when I go halfway to the left, I go up 3. When I go halfway to the right, I go down 3. I can draw that part in. All right, now I do one more period. 4 boxes wide, 1, 2, 3, 4. And this one's going to be 3 pi over 2. Draw my dotted line for my asymptote, and then mimic the pattern I did on the left, the same over here. Remember, if you don't draw these dots, I'm still looking for your curve to go through those points, and I will be judging it on whether it does or not. And there's 2 periods of number 14. All right, moving on to our last 2 functions, cosecant and secant. If you recall, cosecant is the reciprocal of sine. So I'm going to graph y equals negative 2 sine of pi x as a dotted line, and it will be my guide, or dotted curve, I guess. It will be my guide to drawing cosecant. So let's do our setup. Amplitude is the absolute value of negative 2, which is 2 for wave height. Period. Back to 2 pi, no longer on tangent and cotangent, divided by b. b in this case is the coefficient of x pi, and my pi's will cancel, and I'll have a period of 2 with no pi on it. And then phase shift is non-existent because I don't have plus a number here. All right, So here we go. Sine not shifted left or right is going to go through the origin every time. Go back and look at your original graph. And then period is 2. So if I make that 4 boxes, then 2 boxes would be 1, and each box would be a half. So I can put in -1 and -2 over here. And it's got to end by the time I get to 2. So beginning is at the origin, end is at 2. For sine, there's a dot in the middle as well because we're doing the bottom or middle, top, middle, bottom, middle pattern. Like so. So halfway from here to here, it's been flipped down. So I'm going to go down 2 instead of up first. And then in the second half, now I'll go up instead of down. And then we're going to repeat that pattern over here. 4 boxes to the left of this dot. It's the beginning of that period. X-intercept in the middle. Halfway over, flipped down, we go down. Halfway over the second half of the period, go up. So now you can see my dots that are going to help me draw this. So far, so good. Not making it too pointy. A little bit pointy on one valley. But there's 2 periods. And now I need to go make them dotted, okay? I'll draw it back in a little bit better in a second because this eraser's huge. All right, so seriously, dotted, because this is not part of my curve for cosecant. Okay, so draw that in dotted. Now, everywhere you see this curve touch the x-axis, here, 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 and here, you're going to draw a vertical asymptote. This will help you know what guidelines you have to draw your inverted hills and valleys. You can't ever cross an asymptote, remember, or touch it in any way. This will help keep you from drawing it so that you've got one curve on top of another so that it's actually not a function, because you never put more than one hill or valley inside the asymptotes. Because if you had a function value up here and a function value down here, it would fail the vertical line test. So we're only going to put one little hill or valley between any pair of asymptotes ever. All right, now the way we know where to draw them is that we go to each valley and peak. So down here, snip that, flip these ends of the string down, and you get this curve with solidly drawn lines headed toward the asymptote. Here's a peak. I'm going to draw that up. Okay, probably could have gone closer to the y-axis there. That's better. Do I have an eraser that fine? So here's a valley. We're going to draw that U. Here's a peak. We're going to draw that U. And that's 2 periods. I've got a downward opening U and an upward opening U, and that's 1 period. And a repeat of that pattern, that's 2 periods. Notice a couple things. This point and this point touch. The cosine curve and the cosecant curve touch each other at every hill and valley. Notice they don't sit on the x-axis, and notice I never have a hill and valley directly above each other. I also don't have one next to it, like the space next to each one is blank in between them. So if you draw your cosine or sine curve right, then your u's will be in the right places. Okay, final graph. Secant is the reciprocal of cosine, so I'm going to graph 2 cosine x plus pi as a dotted line to use to help me draw asymptotes and invert the u's for the secant graph. So amplitude is absolute value of 2, which is 2. Period is 2 pi over b. B in this case is 1, so the period is just 2 pi. And phase shift is C over B, which is pi over 1. So that's pi, and its opposite, the plus sign, which is minus, which is left. Okay, so I'm going to draw my sine curve with a shift pi units left and a period of 2 pi. So if I make my period 4 boxes, 2 pi, then pi is 2 boxes. All right, I might want to go ahead and label negative pi, negative 2 pi, negative 3 pi. Okay, just labeling every other box, that's helpful. And then normally I would start cosine on the y-axis up at 2, but this is shifted left pi, so instead of starting on the y-axis, I'm going to go left to pi, negative pi in this case. That's where my new period starts. Well, 2 pi is 4 boxes, so I'm going to go 4 boxes to the right and draw the end of my first period I'm drawing, and then 4 boxes to the left gives me another period. All right, halfway between the beginning and the end, I'm going to go down to my minimum value and hit the x-axis on the way down and on the way back up. All right, same thing over here. Beginning and end, middle is down. Halfway between beginning and middle is on the x-axis, and halfway between the middle and end is also on the x-axis. So, here we go. Okay. So now I'm going to go back and dot it. My eraser. That's what I should have done the other one, just get a finer eraser tip. I actually do mean for you to go in and make this dotted because it is not part of the answer. It just helps you draw it well. It's a good drawing guide. All right, so now asymptotes go through every point sitting on the x-axis. So here, 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 and here are my vertical asymptotes. All right, there's another. Now, unlike tangent, the period is not the distance between the asymptotes here because there's asymptotes between every hill and valley, and it takes one hill and one valley to make a period. There's my asymptotes. Okay, finally, I'm going to snip snip at the x-intercepts and go down to the valley and draw the inverted U. All right, at this peak, I'm going to go from the highest point, snip snip here and here, and flip these ends up to make a U that opens upward. And then another downward opening U on this valley. And notice how that's one down and one up is one period. So we've got 1.5 periods. So we've got to come over here and draw half a U here. If you want to draw the rest of the U, you can. And over here, draw half a U. All right. If you feel like just drawing one whole one and not 2 half ones, that would give me down, up, 1 period, down, up, 2 periods. Okay, this is the secant curve. Please remember to draw in the asymptotes and the solid parts, because if you just draw cosine as a dotted line, I can't give you full credit. All right, thanks for listening. Good luck.